This is an atomic blast. This one has a force equal to about 30,000 tons of TNT. It is an awesome yet magnificent sight.
The United States has never been attacked by an atomic weapon. It's remote. The electric light and power industry has long recognized the vital role of electric power in national defense. In the event of an attack on this country, where damage to electric facilities would surely occur, the industry must be prepared to restore required electric service to damaged areas as rapidly as possible. The electric utilities have an excellent record of restoring service following storms and disasters. They have general knowledge of the extent and nature of damage caused by different types of disasters, but they of course have had no experience in dealing with the effects of an atomic blast. Recognizing the desirability as a preparedness measure of obtaining information on the effects of an atomic explosion on electric power facilities, the electric utility companies, through their nationwide association, the Edison Electric Institute, undertook to test electric power facilities at the 1955 Civil Effects Tests at the Nevada Test Site as a part of the Federal Civil Defense Administration's Industrial Participation Program. The objectives of the electric utility participation in the test were threefold. One, to determine the effect of an atomic explosion on a typical electric power system. Two, to determine the nature of the problem of rapidly restoring electric service to affected survival areas in the event of an atomic attack. Three, to determine the relative ability of electric power facilities to withstand the effects of an atomic explosion in comparison with the structures they serve. The pictures you're about to see tell the story of the test and some of the lessons learned.
The headquarters of the Nevada test site is at Mercury, Nevada, about 60 miles northwest of Las Vegas. The Nevada test site is located on a desolate piece of desert real estate, accessible only through mountain passes. On the way to the test site is Camp Desert Rock, where military personnel who participate in certain atomic tests are quartered. Test personnel pass through final security clearance and enter Yucca Flat, where this particular test was held. Yucca Flat is about 30 miles north of Mercury. Here, service trucks are seen entering the test area. This is a panoramic view of Yucca Flat. Note the sparse desert vegetation. To the left of and beyond this typical Joshua tree is the 500-foot steel tower atop which the atomic device was detonated. This is a panoramic sketch of the overall test area layout, which will help explain the test setup. Here is the shot tower which contained the atomic device. About 1 mile from the shot tower was the first of 2 test lines. The second was about 2 miles away. The setup on each of the lines was similar. At the 1 mile line were electric transmission towers, a substation, a line of power poles and associated equipment. Also at this line were facilities tested by other organizations. These facilities included a 2-story brick house, a 1-story wood frame house, 2 specially reinforced 1-story houses, 2 radio towers, a propane gas storage tank, and other miscellaneous equipment. At the 2-mile line, the electrical equipment was identical to that at the 1-mile line. Equipment tested by other organizations at the 2-mile line was similar to that at the 1-mile line. Located there was a 1-story wood frame house, 2 specially reinforced 1-story houses, and other miscellaneous equipment. Also, there were a number of mobile house trailers. Between the 2 lines, there were located other test structures. A short distance behind the 1 mile line was a 2-story reinforced wood frame house. About 1 mile and 1/3 from the shot tower were 3 industrial buildings. Such is the overall layout of the test area. From the steel shot tower, which was about as high as a 50-story building, various test installations can be seen in the distance. The test tower, which dwarfed all other installations at Yucca Flat, was an impressive structure. Here is an overall view of the 1 mile test line, as seen from a helicopter. Note the electric power poles, the electric substation, and steel transmission tower. The electric equipment tested was of standard design and construction. Here are the 2 1-story specially reinforced houses. They were designed to meet building code requirements for earthquake-resistant structures. This is a propane gas distribution pump house and an 18,000-gallon propane storage tank. The 2 specially reinforced houses, the conventionally constructed yellow bungalow and 2-story red brick house. This is a view of a strengthened 2-story wood frame house located a short distance behind the 1 mile line. The pole on the right houses a camera. At the 2 mile line, a bungalow identical to that of the 1 mile line. Here is one of the 2 specially reinforced houses. The camera swings over to the other one. The electrical equipment at this line was identical to that of the 1 mile line. And finally, the house trailers. Again at the 1 mile line, from one of the steel transmission towers, we see 600 feet away the 2nd transmission tower and the electric power substation. Looking again at the first of the 2 towers, it is of interest to point out that this one was knocked over by the blast. This tower is of relatively light construction since it was not designed to withstand snow and ice loads. A heavier suspension design, in all probability, would not have failed from the forces that knocked this one over. Still at the 1 mile line, a piece of industrial machinery is being installed on the side of the 2-story brick house away from the blast. This is to simulate a location behind a factory wall. The vehicles shown here were not exposed to the test, but were merely transportation for project personnel. No commercial transportation was available within the expansive test site. For the most part, project personnel used vehicles provided through the test organization. Now for a closer view of the electric power substation, with its circuit breakers, switchgear, transformers, and regulators. The small metal building on the left houses metering equipment and batteries. An inspector arrives in a pickup truck to look over the substation. As he stands by the circuit breakers, an idea of the relative size of the structure can be obtained. The substation foundations were of concrete, and the construction was essentially the same as that in substations in many electric systems. Here are seen the insulators and wiring on the superstructure of the substation. All the electrical equipment was tested before the blast took place and was found to be in complete operating condition. It was not considered feasible to expose a large generating station to this test. With existing interconnections among utility systems, electric power could be transmitted from distant points if local generating facilities were destroyed or seriously damaged. Electric lines lead from the substation to the power poles that were also being exposed to the test. Here, mannequins display clothing for testing heat effects. Note the male in gray and the one in the white sheet for later mental comparison. Some official observers arriving to inspect the test installations the day before the test. One of a group of Las Vegas high school students holding a televised interview with Dr. Alvin C. Graves, scientific advisor for the Joint Test Organization. A model of the electric power substation used in one of these interviews. Here Charles Collingwood questions one of the test officials. The military also participated in this test. Here is a medium tank, one of several that were located less than 2 miles from the blast. Crews remained in these tanks during the test. A final view of the shot tower seen to the left beyond the Joshua tree the day before the test. The blast went off at 5:10 a.m. on May 5th, 1955. Some observers watched the explosion through smoked glasses. The brilliant 3-second flash lighted the dark skies of 6 states. Great clouds of dust began rolling along the ground. A purple haze forms around the edge of the fireball. The mushroom-shaped cloud can be seen developing as the fireball begins to fade out. Automatic cameras at the 1-mile line picked up these next sequences. The 2-story house goes up as if made of toothpicks. The power poles catch on fire, then the blast extinguishes the fire. This shot shows the blast in the background. The electric power substation gets hit by the blast. Note how the framework rocks back and forth. The wood frame bungalow begins to ignite, then is shattered by the blast. The 2-story brick house. A mannequin in a basement lean-to shelter survives the blast in good shape. The windows and doors are broken out of one of the specially reinforced houses. The other reinforced house. Mannequins next to a Venetian blind-covered window receive the force of the blast. This is a view looking upward from the base of one of the radio towers as the blast hits. Here are some shots of the radioactive cloud about half an hour after the test and of test observers questioning officials. A forlorn Joshua tree is mute evidence of the destructiveness of the blast. Here again is the overall test layout. This is the 1-mile line, the 2-mile line, the 3 industrial buildings, and the 2-story reinforced wood frame house. From the helicopter comes a first look at the 1-mile line after the blast. The electric power substation stands erect, relatively undamaged. Nearby are the crumpled remains of the 2-story red brick house. The wood bungalow is in shambles. 4 of the 15 power poles were knocked down. The 2 specially reinforced houses appear to be moderately damaged. A view of the entire area is one of a great amount of destruction. An aerial view of the 2-mile line shows the electric power facilities all standing and apparently undamaged. Equipment tested by other organizations at this line appears to have suffered considerably lighter damage than counterparts at the 1-mile line. On the ground at the 1-mile line, the electric power substation suffered only minor damage which could be easily repaired. Typical structures it would serve, such as the 2-story brick house and the 1-story bungalow, were in shambles. The broken power poles could have been replaced with relatively little difficulty. The 2 specially reinforced houses after the blast. Another view of the substation at the 1-mile line. Note the damaged instrument cubicle on the left. These next scenes show the 4 power poles that were knocked over by the blast. The heavy aerial cable these poles were carrying provided enough additional resistance to the blast to help topple the 4 poles. This pole fell on the guy wire of the radio transmission tower. Note the transformer that was knocked to the ground and broken. Here are other scenes showing the destruction caused by the blast. Several transformers were knocked to the ground and some wires were broken. The type of damage to electric power facilities was similar to that caused by severe windstorms and was due to blast and flying debris from other structures rather than from the thermal or radioactive effects of the blast. None of the equipment was radioactive after the test. The electric power facilities were not in the fallout zone, and the area was found safe enough to permit repair crews to have entered it within an hour or 2 after the blast and to have remained for a full day's work. If the facilities were in the fallout zone, entering the area so soon and remaining for an extended period would probably not have been possible. Heat effects of the blast did not cause significant damage to the electrical equipment. This next view is a sweep of the power installations at the 1 mile line. As can be seen, damage to electric facilities was relatively minor. In general, power poles and hardware suffered little damage, although in certain instances transformers were blown to the ground, wood insulator pins were sheared off, and secondary wiring was snapped. The hardware on the top of this pole was broken by the roof of the 2-story red brick house. The industrial machine located behind the red brick house suffered only minor visible damage. The instrument cubicle, which housed metering equipment and batteries for the electric power substation, suffered extensive damage. Here an inspector takes a look at what the blast did. Here are other views of the downed poles. As mentioned previously, these poles carried heavy aerial cable that contributed to the forces causing their failure. 2 of the poles snapped off at the ground. The other 2 broke off about 6 feet above the ground. Alongside the substation were the 2 electric service trucks that were exposed to the blast. One remained standing, the other had been toppled on its side. A close-up of the one that was toppled over. The propane gas pump house and 18,000-gallon storage tank after the blast. The tank, which was half full when the test took place, suffered no apparent damage, but the pump house was completely destroyed with debris scattered about the foundation. Lightly constructed buildings suffered severe damage at this line. Salvage work on the 2-story brick house gets underway. Here are some close-up views that give a good idea of the extent of damage to this house, located about 1 mile from the blast. Here is the strengthened 2-story wood frame house located a short distance behind the 1 mile line. Note how the side facing the blast was severely scorched. The undamaged band around the windows was protected by shutters which were subsequently blown off. All windows and doors were blown out. The upper half of the chimney was broken off and lay almost intact on the ground. Close-up view of one of the windows. A broken television antenna. 2 inspectors wearing special clothing and masks for protection against possible radiation first look over the damaged building, then cautiously enter for further inspection. Here are some views of the 3 industrial-type buildings located about 1 1/3 miles from the blast. This building suffered severe damage. This one was specially designed and withstood the blast, best of the 3. The 3rd building, from which an inspector is leaving, also suffered severe damage. At the 2 mile line, one of the specially reinforced houses had its windows blown out. The 1-story wood bungalow suffered relatively little damage except for broken windows and doors. The 2nd specially reinforced house, outside of window breakage, was relatively unharmed. There was no damage to electric power facilities at this line. The clothing mannequins after the test. The mannequin in gray clothing was completely burned up. Note this mannequin in brown slacks. The sun cast a shadow to the right. Under her hand, the shadow is etched on the left. The clothing is scorched except where shielded by the mannequin's hand. The inspector outlines the portion of clothing that was shielded from scorching. The mannequin in the white sheet suffered no visible damage. The white color reflected the heat away. Here are other samples of exposed materials. Samples under the white cloth covering were protected, as the white reflected the heat. This test showed that dark-colored materials do not reflect heat as well as light-colored materials. The inspector opens the sport shirt of this mannequin at the neck to show how the heat passed through the dark design of the sport shirt and burned imprints on the underwear. Similarly, heat passed through the dark design on this dress and burned the imprint on the mannequin's arm. Note how the design of the skirt was imprinted on the white slip. Where the skirt material was folded, no marking came through. Electrical and mechanical tests made on the undamaged electric power facilities showed no changes in values from tests made before the blast. It is significant that major substation equipment, which is most difficult and time-consuming to repair, suffered little damage in an area where typical urban residential dwellings were severely damaged. The electric service truck that was carrying an earth-boring machine was toppled on its side, sliding the machine to the ground. An initial inspection indicated that the truck and its equipment suffered comparatively little damage from the blast. Inspection also revealed that the equipment in the back of this service truck was undamaged. The tires were slightly scorched, but still had air. The gasoline had not caught fire. Body damage to the vehicle was negligible. One of the inspectors gets in the truck and starts the engine without any trouble and moves the vehicle into position to upright the overturned service truck. Although the service truck that was overturned lost its hood, its serviceability was not affected. After making a brief visual inspection of the vehicle, the two inspectors enter it, start the engine, and drive away. An atomic blast does not leave things as it found them.
As a result of this test, the project officers who conducted the electric utility participation reached the following general conclusions. In the event of an atomic attack, it appears probable that electric power service could be restored to a stricken area before conventionally constructed residences could be reoccupied, except in basements, and either before or as soon as industrial plants could be cleared of debris and made ready for operation. The magnitude of the overall repair problem in the event of a nuclear attack would depend directly on the size of the area affected, which is determined largely by the energy yield of the explosion and the meteorological influence on the radioactive cloud. Under conditions of this test, no particular repair problem would exist because of radioactivity. If an area were generally inhabitable and hence require electric power, maintenance crews would be able to enter it and make repairs.